Alright, hello everyone. My name is Paul Kanyuk, and we're gonna go over procedural shading in RenderMan for Katana today. We're gonna start using an example I created in another demonstration, which is how to set up the still life in Katana with some basic lighting. For those of you who watch it, I'm sorry you had to suffer through me creating spheres and toruses in Katana. Um, this is where the real meat of this subject comes in. So I'm going to go ahead and start with that file from last time. There'll be a link in this video in case you want to see how I created this. So what I want to really go over is how to do procedural shading in Katana. I have some demos on how to do this in Maya, also using RenderMan, but Katana is also a pretty powerful platform for doing this kind of work. And I'd like to cover at least the basics of it in this. So to show you what we're going to start with, I'm going to hit right click and hit preview render. Let's go ahead and create a monitor. And there we go. Here's what we're starting with. Let me frame that. This is only a 512 render, so it's pretty quick. All right, so we have a bunch of spheres here. Let's make those look like oranges. This look like a plate, and this look like a table. So I have a still life. One thing I'm going to do real quick is, looks like orange A right there. It needs to be a little higher. So I'm going to go ahead and raise it a little bit. Oh yeah, by the way, if you're unfamiliar with Katana, in order to see your scene in the viewport, you have to actually expand the scene graph to that location. So now there's our still life. Alright, so let's work on shading this a little bit. So right now I just have this default material on everything that I'm going to now replace with more refined material. So let's think about what we're going to do with the orange. So first thing I do when I do shading Katana is create a network material. A network material supports a node network of shader nodes, and for procedural shading, you're always going to have a node network. Even when you're not, you never know when you'll need one later, so I kind of like starting with this node. I'm going to call this, I like to use just the first two letters of the node name as the beginning of the node, NM, and I'll call this orange. And in namespace, you got to give it a location, so I'll also call it NM orange. There we go, NM orange. That's going to be where our shader is. All right, now to add nodes to this, we got to add a terminal. Note there's lots of different types of shaders you can have. Some of this is legacy from older versions of RenderMan, like CoShader. We don't really use that anymore. But we'll mostly be focusing on BXF and displacement. And the cool thing is this node is very extensible. So there might be new types of shaders in the future, and this will, allow you to plug them in accordingly. So let's create a BXDF shader. BXDF stands for basically a surface. BRDF is a bidirectional reflectance distribution function, but there's other types like BTFs and BSSDFs, and basically BXDF is just a generic name for a material. So we're gonna do we're gonna do a PRMan shading node. Pretty much every node in our node network is gonna be a PRMan shading node. What's gonna be different about it is the node type. So let's go ahead and for simple surfaces, I recommend using a PxrSeExpr, and by simple I mean single layer. In a future demo, we're going to go over layered shading. But for now, in this demo, which I'm trying to keep simple, let's just do a PxrSeExpr. This is going to kind of be your workhorse for single layer surfaces. I'm going to call this PSN orange surface. It's always good to name your nodes, because if you have two nodes with the same name, bad things will happen. So make sure to always give stuff unique names. So then we're going to right click on there to get the out node and connect it to that BXDF. And maybe let's try making it roughly orangish as a starting point. And let's see. Right now, we'll get to tuning these parameters later. Let's just make sure we can get some orange spheres. All right, so I'm gonna connect orange to that material to the merge. So now that's gonna be in our scene graph. So view the scene from the render node, and let's do a new material assignment to assign those orange shaders. So I'm gonna do a material assign. I'll call it MA orange. A little space here. Let's drag our orange material right there, and You know, I kind of don't like that it's scoped like that. Well, let me quickly just take away that namespace right there, I think. Yeah, I like them just all being flat in a simple scene like that. So then let's update our material assign to be that material. Now, as for where to assign it, for now I'll show you the very simplest approach, which is just to select your oranges, middle drag them over to add statements, and then there'll just be a list of oranges like that. There's more interesting ways to assign materials, which we'll get to next, but let's just make sure they're actually assigned. So let's do a preview render, drag that into our second monitor thing, and then, yay, orange spheres. So let's see if we can tweak the specular a little bit on it. For that, I like to do a live render anytime you're tweaking parameters on a shader. So for the orange, we enable the live button right there. And then we can right click and go to live render. Drag that here. And then it always takes a little longer to start up a live render, but if you're doing tweaking parameters, it can be useful. So what I want to do is get this to be specular, like there's wax on these oranges. So for that, what we can do is increase the edge color and just make that white. And this is pretty much a plastic shader right here, which is fine for waxy materials. If you start raising the face color, it starts looking more metallic. Note there's a physical if you want to actually dial in indices of refraction and such. But that looks good enough for now. So, all right, we've got the basic shader on it. Next, let's start adding some cool patterns to those oranges. But before we get to that, back to that material assign thing. So just dragging from the scene graph into here is fine. But let's say we start adding more oranges later, and oranges, their names start changing. I like actually using what are called collections for material assignments, and that helps keep your shader assignments a little more procedural and flexible. And I'll show you what I mean by that. So I'm going to clear those for now. I'm going to do a collection create. And now this is a very Katana-ish workflow. This is kind of what the creators intended you to do. And sort of harnesses the proceduralism of Katana. Is that we're going to create, we're going to call this oranges, or even just, yeah, oranges should be fine. Actually, no, we're just going to call it oranges in the name. And then we'll notice under collections, we now have oranges. Then we could add a custom statement. And now we can do things like, well, let's maybe drag in just one of these and then use a star character at the end so that this will match everything with orange in the name. So whether it's A, B, C, or whatever, as long as it's under orange, it's considered an orange. And we can change that later, but for now we'll just do that, and I'll call this CC oranges. And then for the material assign, rather than having that list of paths, we can actually just take that collection and add that here. And let's see if we still have materials on those oranges. Yeah, and it's still working. So this is the more Katana way to do that, is rather than actually having hard-coded paths in your material assign, create collections so that you can, later on, if your naming conventions change, you only need to change it in this collection create, as opposed to figuring out all the various places where you have hard-coded paths. So that's just had nothing really to do with procedural shading per se, but it's a good way to work in Katana in general, is to use collections and cell statements rather than hard-coded paths. All right, so let's go and start making the surface more interesting. Let's make that orange a little bumpier looking. So for that, I'm going to use another PxrSeExpr shading node, and I'm going to pick up a fractal. This is one of my favorite nodes in the world, and it's just basically a fractal noise pattern, but there's so many things you can do with it. And for now, we're going to use it to do bumps. So I'm going to call this PSN bumpy fractal. And I am going to, so one of the tricky things about fractals is making sure the scale and parameters are right. Just for debugging what the fractal does, I usually like to connect it to something obvious. So like take the result gain and pipe that into diffuse gain. So it's just changing the brightness. Ultimately, I don't want this fractal changing the diffuse gain. I want it to do displacement. But just for now, I think that's a good idea to make sure we have it tuned correctly. Another big decision you have to make is what manifold your fractal's working under. That is this a fractal in UV space? Is it in world space? Is it in object space? Is it in the space of some arbitrary coordinate system? This is one of the biggest biggest aspects of the fractal. For now, let's just do object space so that bigger spheres have bigger bumps and smaller spheres have smaller bumps. So for that, let's go ahead and do a manifold 3D, and for the coordinate system, do object. So that way it will stick to the object when it rotates. And I'm going to call this PSN object space. And I'm going to connect the result of that, to the manifold of the fractal. And now that we have this wired up, we can start a live render again and tune the fractal parameters. Right now, I believe in Katana you cannot change the network topology while the live render is going. In Maya, you can. So I'm assuming that this is a feature that will land in Katana at some point. For now, though, get it all wired together, and then you can start tweaking the live render. So I'm going to right-click, go to live render. Go ahead and drag that right there. You should see momentarily some pixels, and what I'm going to do is hit edit there, and let's alright, so we can see we have this cloudiness. That is not a great frequency. Let's sorry, maybe make that quadruple. Alright, looking better. Maybe more than that. Alright, that's starting to look good. Now we can keep going, but one thing I like to do is, what we're really seeing is the fundamental frequency, that is the first layer. And we're kind of raising that in so that the first layer is the right thing. I like to keep that a little lower frequency and coarser than I need, and then start raising the dimension to get more detail. So if we do 1.2, you can start seeing that's the ratio of the higher frequencies to the fundamental, and maybe 1.4. Cool. 1.5. All right, and after a while, it's a little hard to see what's going on. Let's maybe raise the whole thing just a little more. Cool. Now, one tricky thing about tuning this is, sometimes you have to wait for it to refine a little more to see what kind of details you're creating. But that's looking like sort of bumpy and naturalistic. So, again, I don't want this connected to diffuse gain, but that's what I'm doing just to tune what the result is. So I'm going to stop that. And rather than have that connected to the diffuse gain, which you can remove by clicking again on a connection. Well, I thought I could. All right, there it goes. It's gone. And now we're going to create a new PSN for displacement. So I'm going to put that out here. I'm going to call that PSN orange disp. And then we're going to type displacement, find a PxR disp node, and we're going to connect the results of that to the scalar displacement. And then in order to connect the displacement, we need to actually add a new terminal. This is a different shader, and I should probably take a moment to explain exactly what I'm doing here. Let's move this off to the side. Actually, let's kind of want the displacement to be more front and center. Anyway, so a BXDF is a shader that gets executed when array hits an object and basically samples some lights, evaluates some patterns, and basically figures out, well, how much color is reflected. Displacement is a shader that gets executed when you hit render, that runs on every point on the surface depending how close it is to camera and various metrics, and then actually moves the micropolygon of the surface around. So RenderMan actually dices objects if they're displaced into micropolygons. Also, subdivisions are always diced similarly. And then basically, based on the tessellation rate, you can move the points around. This is really powerful for adding detail. It does potentially increase the memory of your scene to do a lot of dicing like this. But after that, it's essentially free. It's just geometry. So displacement is actually not as expensive as you might think. Bump can be a little more expensive because you actually have to do shade more points to find the derivatives. Anyway, that's a bit of a tangent, but basically this is a shader that runs at the start of the render, and then this is what computes the color later. So by default, it's actually, this doesn't do anything. If you click preview render, I think a lot of people, when they first start using displacement, they just get really frustrated because nothing happens. Unfortunately, we gotta, by default, I mean, since it is somewhat expensive, especially with memory, RenderMan does not allow things to be displaced until you explicitly enable it on that object. So I'm going to make our node graph a little longer, and we're going to do a PRMan object settings, a POS node, and we're going to use that to enable trace displacement on our oranges. So POS, trace disp, and we can also use our collection for oranges as well. So we got a collection right there. And then we can, in that node, under attributes, look for trace, and there's a displacement. And it seems to tell you that, oh yeah, trace displacement set to 1. It's 1 here, but not necessarily in the scene graph. If we go ahead and search for it, and hopefully this bears me out, but if we go to trace, interesting, it does say 1. Well, for whatever reason, I actually have to click and go to use local value, and that kind of really forces it to say, hey, we want to trace displacement here. Actually not sure why that attribute said 1. I'm pretty sure this will now get disp in the scene. Nope. No displacement. Alright, let's see what's going on. We have it enabled, we have it connected. We have displacements. Oh, displacement bound. So actually, probably we didn't need to do that local assignment. This is the key. I think when something has a 0 displacement bound, there's no displacement. This is an estimate of the maximum you think the object will be displaced. I'm just going to do 1. Note, you kind of have to set that ahead of time. It's a little bit weird, but you know, just set it to something enough, and there we go. So now we have some displacement going. So sorry, I should really name that trace disp. Sorry, disp bound, not trace disp, because that's what really allowed the displacement to go. So disp bound. Sorry, I gave you guys the wrong explanation initially. Setting the displacement bound to a positive number allows it to go. If you see bits of your object clipped off, your displacement bound is too low. Now this looks crazy. We got a bunch of sea urchins there. That's kind of awesome. You know, we have GI and path tracing with this cool displaced scene, but yeah, we got to tone that down a little. So there's a few ways to do that. One thing we can do is lower the gain on the displacement node, but I often do that as a last resort. I like to just make sure the signal going into it is the right value. So I'm going to do another PRMan shading node. I'm going to call this PSN Bumpy Fractal Remap. That might seem verbose, but you'll appreciate the effort for naming things later when you're looking back into the scene. It always pays off to name something correctly. Let's look for a remap node. This is what I do to sort of color correct and change brightness and contrast of signals. I'm going to connect... Oh, one thing you got to do, this operates on colors, not floats, so we're going to use the color output of the fractal to the input, and then we're just going to use the red channel as the output for the scalar displacement. And then we're going to go to the output max and have that, rather than having an output max of 1, maybe 0.1. And note, you cannot tune this in a live render because the displacement is run as a pre-pass to rendering. It's not in the core of the ray tracing loop itself. So sadly, no live renders for tweaking displacement yet. One day maybe we'll have that feature. All right, so that's cool, maybe a little too bumpy. I mean, it's more in the realm of possibility. I'm sure there is some fruit that looks like that, but not the conventional orange we see in American supermarkets. All right, so let's go and change that to maybe 0.5. I promise I won't tweak it that much longer. By the way, some of you may have seen this demo in Maya or in other contexts. This is my favorite thing to shade is an orange for demonstrating proceduralism. So I've been doing this for years. But the cool thing about once you know how to do this type of shading, it's easy to do it in other packages like Houdini, Maya, real-time contexts. So anyway, that's looking pretty good. We got some bumps on it. let's go ahead and maybe add some folds and stripes with another kind of displacement pattern to kind of emphasize where the stem is and how it's grown. So for that, I'm going to create another fractal, and I want this one to sort of be stripes that stretch along the length of the object. So rather than having the fractal be in object space, I'm going to have this one be in UV space. I'm going to call this one PSN stripey fractal. And you'll start seeing a pattern here. I always have a manifold, a fractal, and a remap pretty much every time I do this. Let's create another PRMN shading node. Call this PSN stripe UV space. And we're going to do another manifold. But this one I'm going to do a manifold 2D, not a manifold 3D. And this pretty much uses the UVs, or as we say in RenderMan speak, STs. There's just a little bit of history there while it's named that way. Anyway, so let's go ahead. Oh, it looks like we didn't actually set this to anything. Let's do a fractal. So now we can connect the result of that to the manifold. And now we can do the result F. Let's I already know we're going to need a remap, so let's go ahead and set up a remap node. Let's do a result F. Oh, sorry, for the remap, we need a result RGB. And I'm getting ahead of myself. Let's actually set it to a PxR remap. Call it PSN stripey disp remap. Connect the result RGB to the input color. Then the result RGB. Well, we got to combine these somehow. So now we have a little bit of a dilemma. We already connected the bumpy fractal. How do we combine it with that? Now, one of the most common ways to combine patterns is to use a mix node, just like a crossfade. And for two patterns, that's fine. But with displacement, I end up adding more and more and more. And this is where I'm actually going to use what's called an SeExpr node. And now this is a little bit of a weird way to just add two signals together, because that's what I want to do. I want to accumulate the displacement. But with what shifts right now in RenderMan for Katana and RenderMan for Maya, this is kind of the way to do it. So watch what I do here. So I'm going to do a PRMan statements node. Sorry, PRMan shading node. And I'm going to connect it to an SeExpr node. This is essentially a node where you can do scripting. This is the same scripting language that is used in XGen. I believe Disney has created this, and Disney loves it. I don't quite love this expression language, but it lets you get the job done. You just got to bear with the syntax. It's a little bit weird and kind of unforgiving. So you'll notice we have float inputs and color inputs. What we want to do is just add the float inputs together and set that to the output. So I'm going to set the result R and connect that to float input 1, and then take result R here, connect that to float input 2. So to add them, you do $out. You use $sign for new variables that you create. But for these parameters, you do not use a $sign. This took me forever to figure out. I was really frustrated. Anyway, float input 1 plus float input 2. Follow it with a semicolon. Makes sense. But for the last line, you simply state the variable you want to be the output out, and then you do not use a semicolon. Now, as a programmer, I was just... This was unnatural for me, but this is how it works, and it's fine. You can express really cool things with it. It's a great language and gives you some flexibility without having to code, other than this little scripting. But yeah, this is kind of how to add nodes together right now. Hopefully there's a better way to do that in the future. One nice thing about it is I checked, and if any of these inputs are always 0, the node doesn't get evaluated, so it's good at being able to lazily pull whichever inputs are needed. So it's kind of efficient, even though this language, you don't want to do too much in here necessarily. So what I'm going to do is take the results R, or the result F rather, and connect that into the scalar displacement. So now these two things should be combined. I'm going to just I won't remap it, and I'll just show you how awesome this looks before changing anything. So I'm just going to do a preview render, and then we're going to have to set some remap values. Yeah. So, well, that's interesting. Actually, one thing I forgot to do is we didn't even change any of the fractal parameters. So before we get ahead of ourselves, I'm just going to connect the old thing back to displacement, leave that there. Oh, I'm going to call this the SEExpr node, PSN SEExpr disp_accum or disp_add. And then what I'll do is for the new pattern that we created, I'm going to connect that to the diffuse gain so that we can actually debug this. And I'm going to do a live render. So I'm going to right click on it, go to live render. And the reason I can do this is because I am just modifying the diffuse gain, not the displacement here. So I just want to make sure that the stripy fractal is tuned correctly. So I can barely see what it's doing. So I'm going to go ahead and maybe increase the frequency. Maybe increase it some more. And there we go. There's our fractal. Wow. That is... Because it's in UV space, you're going to have to change your values. But you can see it's actually kind of stretched along the equator. We want to stretch it in the opposite direction. We want it to go along the length of the object. So I'm going to go to UV space right here. And let's do scale T. Maybe make that a little longer. Yeah, 2 is looking okay. Maybe 4. Cool. So yeah, now we're really seeing stripes on it. And that's actually not too bad. All right, let's call that good enough. And now let's again remove it from the displacement. The diffuse gain. And then let's connect it. The result F back to the scale displacement. And again, you know, until we tweak that remap, this is going to be really weird looking, but let's just see where we start. Awesome. So that is a little too high. So we're going to need to crank that way down. So let's maybe go from 1 to 0.1, 1/10 of that. It's pretty cool, though, that you can do that. So keep displacement in mind for interesting effects. It is a great feature of RenderMan that is well supported. All right, so that's cool, but one of the things I'm noticing is that the object's getting a little bit bloated looking. We're only displacing out right now, but to preserve the original silhouette, you might want to also displace in. So I'm going to go to that remap, and while I kind of like the height relative to the bumps, I'm actually going to just take half that to 0.5, and let's make it go negative to 0.05. And let's uncheck clamp just to make sure that we aren't clamping anything at 0 or 1. So now it's going to actually go a little bit negative as well as go a little positive. And let's see what we get. You might notice there is a seam on the backside of our spheres. Because we are doing UV space for the fractal, oops, let's drag that in here. There's going to be a UV seam, so that's kind of unavoidable. So all right, there we go. So we actually were able to shrink it in a little bit, keep back to the original silhouette. What I like to do in this case is, you know, just rotate your object so you don't see it. So let's go ahead and go to our viewer. And go to our main cam, and let's maybe rotate these spheres so that we don't see the seam. So let's select that guy. That is orange B. So if we go to orange B and then rotate it, I don't know, maybe we're on the x-axis by -40. Yeah, that'll do. This guy, orange C. Let's also put it way negative on the x-axis. Cool. And same thing with orange A. Let's tilt it back a little bit. By back, I mean, actually wrong axis. Maybe this axis. Cool. All right, now let's see if we don't see those UV seams anymore. And you're probably like, really? That's your solution? You could do world space and stretch it along the z-axis. Probably would be a little better, but for now, it should be fine. Cool. All right, so now we don't see as many seams. We just need to de-intersect one of our spheres. This guy right here, sphere orange C. Let's move orange C forward a little bit. Looks like that's the Z-axis. There we go. And then maybe close it in a little bit here, a little less negative. Maybe it's, anyway, close enough. Sorry, this is not the point of the demo, is composing the still life procedurally. So, yay, all right, so we'll call that good enough. And, you know, we can go a lot further with these oranges. We can, you know, we can add dirt and dust, and that's actually something I often do in my RenderMan class, is write a shader that ages over time. But I think this gives you a little bit of an idea on just how to do shading. I think the critical things here just, you know, is fractal, remap, manifolds, using an PxrSeExpr to add some patterns. And this is kind of the basics of procedural shading. Before we, I think, close this or end this demo, let's just put a more reasonable shader on the plate and then a more reasonable shader on the table, so we at least have something a little prettier looking. And we can take this maybe further in another demo. And that'll be a review of how I set up the shader to begin with. So for the plate, I'm going to do a new network material node. I'm going to call this NM plate. And let's go add another BXDF. And add a Pixar shading node, PRMan shading node. And then do another surface, PXR surface. I'll call this PSN plate surf. Connect that right there, and then again move that into the merge. Also, while I'm at it, I'll go ahead and create one for the table as well. So let's go to create a network material. I'll call this NM table. And then create a new PRMan shading node. Sorry, it's a little bit of a review, but you know, this is something we'll be doing a lot. So table, table surf rather, and then create a surface. Connect that to, well, we got to make sure to add a terminal for the BXDF. Connect that, and then connect that to the merge node. And again, material assign to actually assign the two. So I'm going to go ahead and create another material assign. Call this one MA table. And call the other one MA plate. And well, before I encourage using collections, just for expedience, I'm just going to drag these guys here. So drag the table for where you assign it to. What are you assigning? The network material table. Same thing with the plate. Drag that to the material assign, and then get the actual plate node under the cell. So now we can make these live renderable. So we can do a live render and hopefully tweak the parameters here to make something reasonable. Let's go and drag that here. Cool. All right, so let's make the plate more like, I guess, white porcelain. What we can do is I'll make it white. That's a start. Maybe a little shinier. So I'll go ahead and make the edge color white. Cool. Maybe it doesn't quite need to be so diffuse, so I'll bring that down just a little bit. But that's pretty much the plate, so very fancy shading there. You know, we can connect some colors to add patterns, but it looks like roughly like a plate. Though I think actually we could, composition-wise, maybe move it a little that way, or maybe move all the oranges this way. I told you guys we wouldn't do that, but one thing you could do if you want to yeah, I'll show you a cool trick. Now that we have that collection for the oranges, if we want to move them all at once, we can use a transform 3D node. And I'll do it oranges. And then for the path, we can, oh, I was hoping we could give it the collection, but looks like we have to, well, here's something we might want to do. Well, anyway, let's maybe select these three. Wow, we can only do one object at once. Oh, that's so lame. Well, one thing we could do is, I guess maybe create a new scene location. Whatever. Enough of that idea. Let's actually just focus on the table. Clearly this is unedited, this video. Anyway, let's maybe add a wood pattern right there. And for this, I want to introduce open shading language. And for those of you that don't know, open shading language is kind of, it's a really fast, just-in-time compiled language for running in a path tracer. It's used by RenderMan. I believe it's also used in Arnold as well, and perhaps some other renderers. It's actually open source, so it's not something Pixar necessarily owns, but a whole community develops. It's kind of the successor to RenderMan shading language. Now, you can find examples of this in the render. When you use RenderMan, there's a way to download examples from it. This is the examples for RenderMan 21. Inside the scene pattern OSL shaders folder are examples of how to use open shading language. And there's this cool oak shader right here. If you open with Notepad, is a cool example of how to do some fun pattern generation using open shading language. So let's go ahead and try to use this oak shader for the table. Now, in order to use OSL shaders in Katana, you need to make sure they're on the RMan shader path. So if you go to your system environment variables and then go to environment variables, you'll notice there is an RMan shader path. And you can actually have a whole number of paths here. And I believe we're just going to use the ones, I put them in this folder called OSL shaders. And that, for me, just contains a copy of these shaders right here. So I have access to oak.osl. And this is really cool if you want to, basically write your own nodes. Note, there's some performance issues with mixing OSL nodes and C++ nodes. And at Pixar, we've worked really hard to deal with that. For now, though, if your performance is not completely critical, don't feel stopped by that. But talk to me later if you want to know a little bit more about the details of that. So anyway, what we're going to do now is create a PRMan shading node, and let's see if we have oak in our shader path. Yay, oak. So this is a compiled OSL node. I probably should have another demo just on OSL because it's interesting, but suffice to say, you should know at least how to get access to these. I'm going to call this oak, and if we go to parameters, there's our parameters, and let's just connect the color of the oak to the diffuse color. Note we also have a specular and roughness output. Might as well connect those as well. Let's connect the roughness to our primary specular roughness. And the disp, well, that's a float, and let's just do something different. Let's use it for bump mapping. So let's do a PRMan shading node. And bump mapping, so is rather than actually moving the points prior to the render, it will, during the render, bump mapping will use that height to just bend the normal. And there's some cool, you can get some really nice detail using that, but it won't change your silhouette. It is also slightly more expensive than displacement because to bend the normal, you need to know the derivative of the pattern input. So you have to evaluate it 3 times for every point you shade. So be careful. I can call this table bump. But because, you can get some really nice detail with it. And also, let's connect the displacement to the pattern input. You'll notice when you connect the result N, there's actually many bumps you can use. So you can actually have different bump normals for different lobes on your shader. This is great, but it can be a little dangerous. because reusing the same normal helps simplify calculations, especially with multi-layer shaders. So unless you really need these features, I recommend always using the global bump. That has the potential to be a lot cheaper. Alright, so now that we have that and the live render is set up, and for these we can go ahead and do a live render. Also, bump, unlike displacement, can be tweaked during a live render, because it is not part of that pre-pass to move the micro polygons. Alright, so let's see what we have for oak. Well, that's looking fun. That is looking really chewed up. I have a feeling the gain on our bump is a little too much. So let's go ahead and change the scale, maybe to 0.1. Maybe let's do 0 just to rule out what that's doing. Yeah, so the bump is definitely doing something pretty extreme. Let's do just a little bit of bump to get some shaping in it. Now, so the pattern, that's looking pretty cool, but let's see if we can tweak it a little bit. I feel like it should be a little higher frequency. Also, these straight stripes are bugging me a little bit. So let's maybe increase the ring frequency. Cool. Looks like we have more rings. Ringiness. Maybe make it more ringy. Cool. Well, that's looking kind of fun. Looks more like fancy wood. Maybe make it a little grainier. Note you should actually look in the shader to see what this is doing. But sometimes it's fun just to play around with parameters. And let's see. Ring unevenness, sharpness. Let's see what happens if we increase the sharpness. Cool. Oh, so that's very sharp. Maybe 0.1 is kind of better. And yeah, you know, you can play around with this, make it look like however you want, but let's call that our still life. So yeah, that's just a quick demo on how to shade in Katana procedurally. For next steps, I'm going to have another demo on how to shade a city. It's a much larger environment, and we're going to use not just purely procedural nodes, but textures as well, including triplanar projection mapping and baked curvature and occlusion. So if you're interested in seeing a little more involved demo, I'll hopefully be posting one shortly. But I think this is a good example of what you can do just with Katana without using any external assets. Just this is what you get with Katana and RenderMan, and it's a fun little test. As an exercise to the viewer, if you want to take this further, yeah, try making different colors on the oranges and maybe being able to make them age over time with a multi-frame render. That's one of the assignments in my class that I usually teach. So anyway, we'll go over that later. Thanks for watching, and let me know if you have questions. Thanks.